Okay, welcome back. This video will continue looking at slope as it applies to both grade and pitch. First of all, grade is used to talk about the slope of a road. Okay, grade is normally expressed as a percent. The steeper the road, the higher its percent grade. Percent grade is just the slope. That's the rise divided by the run times 100, and this 100 turns it into a percent. Okay, so just a couple of points here. Road grades must be kept to a minimum because a steeper grade limits the size of load that can be hauled. So our first example is looking at Martin. He's driving his truck on the Trans-Canada Highway. There is a sign indicating that there is a 7% grade. So if we are asked to find what is the slope of the road as a fraction, we're looking to put 7%, which is the slope, which is the rise over the run. We want to write that as a fraction. That is just going to be 7 over 100. Okay. If we were asked to write this as a decimal, we'd write this as 0.07. Okay. The angle of the elevation of the road we can find by using the tangent of theta, and tangent, remember, that's just equal to the slope. So if we say the tangent of theta is equal to 0.07, then we can use that inverse tangent button. And if we do that for 0.07, that's going to tell us the angle. And that angle, if we punch that through our calculator, we end up with 4 degrees. Okay, if we keep going down here, if Martin is driving for 5 kilometers, what vertical distance or rise did he gain or lose? So I like drawing pictures, so I'm just going to do that here. Draw a little picture. This rise is what we're looking for. If Martin's driving his truck, he's going to drive 5 kilometers. So I can draw a little truck here. Okay, please no laughing at my artwork. And this will be 4 degrees. Down here, this one's a little tricky because we have to use another trig ratio here. Here we'd use sine. If we're talking about this 4 degrees, we'd say that x is the opposite side and 5 is the hypotenuse. So our ratio that we'd be working with is sine. So the sine of 4 degrees is equal to x over 5. Put this over 1 and cross multiply. You end up with x, or that rise, is equal to 5 times the sine of 4 degrees. Okay, plug this through on a calculator, we get 0.349 kilometers. Okay, if we wanted to put that into meters, we could do that. 3.49 kilometers is just 349 meters because there are 1,000 meters to a kilometer. Okay. Okay, so just at the bottom, I just put a little diagram here showing the different types of roofs. The most common roof that we see is likely the gable roof, but there are some other styles of roofs there that you can check out that's used in construction quite a bit. As we get down to the second page, if we're talking about pitch, so pitch is used to describe the slope of a roof. Okay, so pitch and grade are just different words for slope. Okay, so this roof shown is a gable roof. You have, well, gable roof, you can look on the first page to see what that looks like, but it's our roof that looks like so. It's going to have a rise and a run. When we are talking about pitch of roofs, it's common to put 12 in the run. So all of these numbers are just the different run values. So if we're talking about a roof pitch, and you're talking about a 12-12 pitch is going to be much steeper than, say, a 4-12 pitch. That's just some common interest stuff. Okay, so if we look at an example here, if we're looking at our diagram, what we are looking for is how wide is the shed. We'll highlight the whole thing there. Okay, we have our left side pitch is 3-4, and our right side pitch is 8-9. So we'll just keep that in mind. I'll put this on the diagram. So in this first bit, so I'm just going to write this down again. Slope is equal to rise over run. So I'm going to look at this left side first because I'm given this value of 3.2 for the run. So our slope is 3 to 4. Our rise is some unknown h, and our run is 3.2. and we can cross multiply and find that h is going to be equal to 2.4 meters. So this is 2.4. Okay, now I'm going to use that number for the height in the right side. Just going to make a comment here. It's the right side. I'm going to use the same formula. Slope, excuse me, is 8 to 9, and that's going to be equal to, this time our rise is 2.4, which we solved for from the first part of the question. That's going to be over this value L. Cross multiply, we get L is equal to 2.7. So the width of the shed is just going to be 3.2 plus this 2.7 meters that we just found, for a total of 5.9 meters. Okay, well, it's just an application of using pitch to find some different numbers. Okay, last question here. If we have the roof of a tool shed as a gable roof, so a gable roof, again, is one that comes up, comes back down, and I could kind of draw this. So this is the house, this is our roof. Okay, our pitch is 2 to 5, or the slope is 2.5. Okay, if the whole shed is 7 feet wide, there's a bit of a trick to this question. The whole thing is 7 feet wide. We have to split this thing in half, because what we're looking for is the rise of the roof. We're looking for how tall it is. So we're looking for the rise. Maybe we'll just label that H. So we really want to just look at 1/2 of this. The pitch is going to be the same on both sides. So if we look at just 1/2 of this thing, the base is only going to be 3.5, or half of 7. Okay, we're looking for the rise, so we'll put an unknown there for that, and then we're going to go back to our slope is equal to rise over run. Our slope here is 2 to 5. Our rise is some unknown x, and our run is 3.5. And we'll cross multiply. We'll find that x is equal to 1.4. And oops, I've used two different variables here. This x and h, those are actually the same thing. So maybe I'll just erase this h here and put an x for that. Okay, so the height of this thing would be 1.4 meters. Okay, hopefully that gets you going. You can go ahead and try some worksheet questions on working with grade and pitch. Bye for now.